cause too much pooling of your lymph or blood. Our next speaker is Kenneth Bruskiewicz. He is our leader of the SFU lifespan branch up on the hill up there. So he has a talk prepared for us today. So here, and I'll just go over to Kenneth.
Okay. So as I said, I'm Kenneth. I got a lot of good acts to follow up on, so let's see what I can do. So the title of my talk is also the subject of my talk, Ethics of Genetic Enhancement. It's a broad thing, but that's what the next 20 minutes are for. If I was going to be terse, okay. Okay, so I'm just going to give a little bit of an introduction first, an overview, some quick acknowledgements, and a bio. Here we go. So if I was going to be terse, I think the biggest takeaway of this talk is hope for the best and plan for the worst. That's being a little bit glib, but overall I think that's what it is. Ethics, especially with respect to genetic enhancement, is a complicated thing. I'm not here to decide for anyone. I'm not here to really say that this is the best course of action. I'm just here to offer some pointers which I think will help structure our thinking. It's too important an issue to leave to one college student to decide. So here's the core argument I'm going to try to make. Mutation is underrated as a cause of health deficiencies, poor health status, diseases like Alzheimer's, schizophrenia, autism. These things may have genetic causes, and I expect these things to get worse or more common as a result of this underrated factor. As a result, if you want to slip the problem at the throat, genetics will have to become a four-point leverage. The nice thing about treating these things as genetic diseases, things that we don't like as genetic diseases, is that we get the possibility of more general fitness for free. I'll explain that in a bit. And, okay, I admit this is going to sound slightly like eugenics, just to get the elephant out of the room. Yes, Hitler did bad things. He was the bad guy. He was racist. He was a fiend. But overall, I think that just means we have nowhere to go but up. We can do better. But yeah, I qualify here by saying that we can only do better if we get it right. And at the end of it, I may, if I have time, I'll provide some action goals. If not, we'll just head it to panel. Some acknowledgements. Most of my information, and actually the article that started all of this, was a long-form piece at quadrant.org, an Australian editorial paper with these two articles. They're going to provide way more information and much more better argument than I will ever give in the next 20 minutes, but that's only because of the time constraint. Stephen Hsu, who is a researcher at the Beijing Genome Institute, he has a talk called Genetics Intelligence that was also quite useful. The work of Robert Sapolsky, who is a biologist, particularly with behavior, and some friends of mine. My credentials, moving on. Here's some pictures of me. As you see, this is probably my favorite picture of me. I'm pretty much a mix of East and West genetically. I love this stuff. This is why I feel like I really need to bring this out. And I'm 2.8% Neanderthal. When I wake up in the morning, this is how I feel like. Okay, now to the serious stuff. Okay, so I'm going to provide some definitions, mainly because I want to kind of standardize the argument that we're having. Definitions are important, particularly for something so complicated. So I'm going to try to simplify things, but only as much as I need to in order to make sure that I can commit to things. What do I mean by enhancement? Well, I think enhancement is anything that improves fundamental human capabilities, particularly things that kind of work at our limits and then help us boost past them. The transhumanists in the room may or may not agree with this definition, but I think it's a good working definition. Some examples of enhancements, mental, maybe nootropics, which are cognitive enhancements, became more popular in the mainstream. Physical enhancements, prosthetics for those who do not have limbs, I imagine would be quite an enhancement for them. And whatever is banned by the Olympics, I think should qualify as an enhancement. There's a little joke where it's like, okay, if you want to see what works, just see what they're not letting you use. Computers, I'm not so confident that they qualify as an enhancement, at least not in the sense that I think will be important. Training could be an enhancement, but it's generally hard. Training is some of the most difficult. Basically, when you're trying to improve something like intelligence, training programs tend to dissolve in sort of their effect once you start controlling for a lot of variables, so it's not going to qualify here. If anyone wants to talk about really cool stuff like computer and brain interfaces, we'll talk about it over here. Principles, what do we care about when it comes to enhancement? So I have these three sort of points which I'm going to use as my evaluating criteria. Is the enhancement high impact? Is this the thing that we want to help us get better with? Is this something that's going to be better for us at the margin? Does it make sense for us, or is it just something that's so petty that we really don't want to care about it? At the margin essentially means for the next best thing that I can possibly do is it this thing. Extrinsic versus intrinsic. Some of the things I mentioned up here, I qualify as intrinsic. So nootropics are something that help improve my memory as a process, rather than substituting that thing with better memory like a computer does. And in this case, I think intrinsic enhancements are the things that where all the money is at. Positive versus negative. By this I mean, are we trying to manage risk? Are we trying to manage cost and downside? That's negative. Or are we trying to actually get gains, which is, I think, positive. We're going to be actually focusing on negative. That is not to say that genetics can use both positive and negative benefits, but negative, as in risk management law, should be very useful for us to focus on. So yeah, genetics is actually is nice because it's intrinsic. It's improving fundamental capabilities that, instead of substituting our capabilities, positive or negative genetics, genetic enhancement can actually be both, but we will focus on negative. And heredity makes it so that it's a high impact thing at the margin. Heredity is it's not a complicated concept, but it's a very misunderstood concept. It essentially means how much of a trait is explained by genetic variance over variance of other variables. Like if we change this genetic thing, does that change the trait? And by what proportion does it change the trait? Or do we think that it changes the trait? Heredity has this connotation that it's a static thing, that somehow we have built inside of us a certain amount of capability. To the extent that that's true, I think it means it's high impact at the margin for us to look at genetics, because it means that we're actually dealing with the fundamental thing that may constrain our traits or our behavior. So what I mean by genetics, I'm going to paint broad strokes very quickly because I want to stay within the time frame, and I'm going to tread lightly on controversy. I'm going to simplify by saying that the metaphor of genetics as code is very useful for us because it lets us think of code in two ways. One, when we're transferring codes, errors compound as the more transfers that we make. These errors we're eventually going to call mutations. If codes are editable, which essentially amounts to us changing the ways that we may want to encode for certain proteins, which downstream links to a certain phenotype, meaning whatever trait we would like. This is negative enhancement, and this is positive enhancement. Hedging against this is negative enhancement. Some points of interest. I will be using an unconventional definition of fitness as well as a conventional one. The conventional one is essentially stating that we have fitness as far as evolution, making us more fit for whatever reason, and unconventional means culture wanting a certain trait. The two are not related, not completely. So we find that, for example, if you're a very much long-term planner, that's very nice from a cultural standpoint because long-term planning allows you to do things like build better businesses. But unfortunately, long-term planning also leads you to delay certain decisions which affect conventional fitness, such as having kids sooner, which will result in a certain trade-offs versus having kids later. As we'll see. Mutation is things that are wrong with the code. Trait distribution, people might be familiar with the dreaded bell curve. That's something that I think is important as we're going to see. Okay, genetic enhancements, I think it's kind of obvious. We want to either change the code so that we can have more positive traits of a certain kind, or we want to hedge against the errors in the code so we don't have the traits that we don't like, such as diseases. Okay, so this, like I said earlier, this sounds very familiar, but not in a good way. Here's a list that I found on Wikipedia of the old versus the new forms of genetic enhancement. Some of these are very awful. Some of these you would never want to see happen in Western society, but they did. Things like forced sterilization, things like, tax incentives, not so sure. But the big three down here are basically saying, okay, so we have people who have a certain phenotype we don't like, a certain genetic disease, we make sure they don't have kids. Or they're criminals, too bad, no kids. These are horrible things. These are things that even the United States did practice for a very long time, from 1913 to 1967, in 16 to 29 states, I believe. They eventually held up in Virginia versus the United States, but it was still a very consistent practice. But now we've got options, and these options are why I consider now to be different. We have things like, so we have genetic engineering, which I assume involves CRISPR. in vitro fertilization, and screening. These things are also genetic enhancements in the sense that they can make us change the genome, but the fact that they exist lets us get around some hazy or some poor ethical concerns that were more present here in the old regime. How do they do that? These ideas are old. So what went wrong, I think, is that the old way of doing things really screwed with our sense of agency. By agency, I mean something to the effect of the ability to control our own lives. The three ways that they screwed with agency is that they basically made a bunch of choices that we ought to make condensed into a single authority. Another way they screwed with agency is that they made us look at our behavior and say, is it all just atoms moving around it, moving at the bottom, and are we just not determining our own actions? That's a threatening concept. And finally, they screwed with our sense of agency by making us challenge our sense of personhood, such as the abortion debate, which is something that has been, which does factor into genetic enhancement, but I argue it's not going to be as big of a problem as the first two. So why is now different? Well, we have technologies now that do three things for us. One, they make very specific changes in this case, I think most of the time we're just going to be operating on embryos, but they also make specific genetic changes. They bring us to sort of ideological zero, meaning that they give us a starting point that lets us figure out how much control we would want, in whatever proportion we would want, rather than having to start from a big totalitarian regime and having to work backwards from there, which is much more difficult. And thirdly, they give us a better understanding of personhood, which allows us to make better choices ethically when it comes to how we want to do things. Why is it now different? The specificity comes mainly from the CRISPR technology. There's a picture down there that lets us edit individual snips of genes, or basically remove the pieces of code that we don't like and add or repair the pieces of code that we do like. It's a negative. It allows us to give us both a negative enhancement. The low-level sort of risk management is easier than ever because of the fact that we can use these pieces of technology to improve ourselves in a way that's specific. And it's positive. The positive enhancement is improved because with in vitro fertilization, we have a little bit less of a problem when it comes to having to ask in order to figure out whether we want to adjust a certain trait. To contrast this with the previous situation, before we would basically have to treat people like a breeding program. And unfortunately, that's not something that actually goes very well with people. I say with my tongue in my cheek. It's true, it doesn't. So instead of having to deal with this problem over generations, we can now just say, okay, we just have this embryo, we can make whatever edits we like and be very specific rather than having to evaluate people on one number or another number and making them have kids a little bit later. The ideological zero comes from the fact that now that we have these technologies, they can be provided as a market good. If these technologies are market good, we start from laissez-faire and we just add regulations as we go. It gives us an entire political spectrum of choices to choose from when it comes to actually figuring out what exactly is it that we want from genetics. So now we have the ability to be very specific, and now we have choice. Now is the question of how do we make that choice. I mentioned personhood. My current definition of personhood is that if you have 100 blastocysts, which is basically a bunch of the consequence of a growing embryo, first it just starts out as a bunch of small cells. I don't think it's actually conscious. That's going to be a controversial thing for some people. But if we work with this definition, we do end up having a lot of benefits with in vitro fertilization, which can end up paying off in the long run. We have to think about this now. This is an example of some research done out of the, I think it's the Beijing University, I'm not sure, but all the researchers are Chinese. In April 2015, they actually did use CRISPR, that selective tooling, on non-viable embryos that couldn't have become children, but they wanted to experiment on them anyway. There are people that are doing this research right now, and we have to question whether or not it's good for us to continue doing this research and to what extent. My motivation for genetic enhancement, two things, mutational load and the G factor. I mentioned earlier that I'm going to focus on mutation. One of the reasons why is that one reason why I expect greater diseases from mutation is basically because people are putting off having kids. For women, they pass around 50 mutations, I believe, for each child. I think that number is static, but I'm not sure. The reason why I believe it's static is because for women, most eggs are created around puberty, I think the supply stays relatively constant, and it just goes down from there. For men, though, they basically gain more mutations as time goes on. If you look at those three sort of snapshots, this was an Australian study that was done. 20 years old, 20 mutations, 40 years old, 65, 56, 130. That's a non-linear rate. So the older you get and the longer that you put up having children, the more mutations you're going to pass on to your children. And the higher I expect the odds are of certain diseases coming out as a result. So either we say have more children sooner, got a chance. Maybe people are willing to do that, but I don't think they will be. Or we kind of say, okay, now that we have this technology to fix that, let's deal with it. The G factor is a little bit more of a controversial argument because it's essentially the bell curve idea. That somehow we have all these different positive traits and they intercorrelate into one number that summarizes the entire thing. It's controversial, but I think it's important to still understand. The reason why is because we have these three traits here, IQ, conscientiousness, and empathy. They're not completely related. Most of the things inside of IQ are explained by the G factor, the other ones are not. But they all, I think, fall under a bell curve, which means that they're explained by many different variables. As a result, we should believe that if these things are highly heritable and they're explained by many different variables, perhaps there are lots of genes in the genome for which that you require in order to have these traits be expressed to their most positive extent. Essentially, the bottom line is that if something like IQ is distributed across the genome, we don't want more edits and more mutations to be passed on over time, and we don't want these edits, if these edits do occur, we want to make sure they're positive rather than negative. The accumulation of mutations across the entire genome would perhaps, I suggest, mean that these traits, something like IQ or conscientiousness, we would expect them to either go down because of the fact that it requires so many different genes to function. Bottom line, I think we can avoid moral bankruptcy, meaning that we can actually, because we can be selective, because we get to choose our regulation, perhaps there's hope for fixing some of the problems we have with mutation and improving some of the traits that we maybe try to explain away but are still there, like the G factor. But we have to make sure we do it right. So in the end, what matters? What do we actually need to think about in order to ensure that we can get this question right? I have factors, questions, scenarios, and some gotchas. Quick list of factors. Some of the facts we probably want to agree upon are sort of genetic model, our sense of how genetics elicit behavior. Complicated question. A certain gene can explain a large amount of trait, a large variation in phenotype. If you knock out one gene, you get dwarfism. But many genes can also explain a very large extent of a phenotype. If you knock out a couple of genes here and there, you don't reduce IQ too much, but you do reduce it by a couple of points. We need to get our concept of agency right, and basically other things that I explained earlier. Rate of human evolution I put there because I figured that we actually need to understand whether or not we're dealing with a core set of traits or if the genome is changing. It does change the thing from a mutational load problem to a trait selection problem, which is different. The response, the things we should consider are whether our values are convergent towards the same kind of thing or whether they're very different. Who do we make the technology available to, and when are we going to make the technology available if we can actually change it? The positive and negative externalities, who gets affected other than people using the technology and how, and the preferred degree of regulation a priori. Most of us are in a democratic society, so we usually prefer less regulation, but others might not think that. Okay, I'll just explain all this. Some qualifications are here. I can probably bring them up, like the Flynn effect in the panel. Okay, the image didn't turn out too well. But basically, the bottom line, I think, is that maybe the best case is that we want things available for the majority. We want to focus on negative enhancement, and we want citizen regulation to drive those. What I mean by this is the justification I have for why this may be a good place to start, maybe not to end up eventually, but to start, is that if we piggyback on a lack of controversy when it comes to editing the genome to remove genetic diseases, then we end up improving a trait which may also be affected. Like what I said with the G factor earlier is that it might be a sort of indicator of genetic health. This is the case, that if we improve mutations overall, then we do end up with some greater fitness later down the line as a result of these traits being intercorrelated. Trait selection, unfortunately, ends up getting into some really hairy stuff, so which kind of gives negative enhancement of benefit by fiat. The value of trade-offs, there are certain traits that have different trade-offs, and we we have to navigate those trade-offs. Things like creativity and hard work, they actually are inversely correlated to a little extent, and also things like agreeableness and creativity. You generally want to be a jerk before you end up thinking of good ideas, because maybe you defend your ideas a little bit better. These are trade-offs that actually we have to think about, and that's what trait selection is about. But mutation is something that people may generally agree upon, because it has to do with health. There's also the precautionary principle of trait selection, which in the end makes us think, okay, well, do we know what we're doing when we're actually adding new things into the system? For something as complicated as genetics, the answer is probably no. So that's why we think that just getting ready mutation based off a known good code would be a safer bet. This is the final slide. What matters? There are some other explorations we can do. The one I will mention due to lack of time is kinship matters. Kinship is a resource. If you end up having to change someone's genome and they end up not being related to their parents anymore, or not to a large extent, then that's something we actually have to understand before going forward. That's one thing that I think is really important, because it's something that most people don't really realize at first. There's other stuff I want to read, but I think I'm out of time. Action goals we can grant later. Last thing, freeze your kids. Basically get your sperm frozen and your eggs frozen and make sure they still